What the one?
Prasad, I made you a present now.
Good morning, sir. Okay, sir.
Good morning. I think looking zero. Now it is looking zero.
Sir. Hello, sir. Smita, yesterday I have sent some questions and with question numbers. And Teja, have you tried those questions? At least have you seen the questions? Please respond. You can use your mic. So every time typing is not comfortable. What, Teja? स्मिता जी कुछ बोलिए ना. Okay. Teja, so you haven't tried it. And what about the others? When they come, Samiksha. So yesterday we were doing grammar. If a grammar is given, what is the language? So there were some questions. We did this. Now here grammar is given. We have we found the language. Now from language to grammar means if a language is given, what is the grammar? That's what we do. Now take the question. Construct a grammar. Take the question. Construct a grammar which can generate all palindromes over set A comma B. Over set A comma B. Okay. Now tell me, what is a palindrome? What is a palindrome? Okay, numbers such as 1 to 1. Okay. Here, what is the least palindrome? The palindrome means from left side you read the string or right side you read the string. You will get the same string. So even though we reverse the string, it will be the same. Example. Example ABA. Okay. ABA, double A, triple A, BAB, ABBA, and among all these, which one is the smallest string? What is the smallest string? What is the smallest string? The smallest thing is AA. Teja? The smallest thing is A is palindrome, B is palindrome, even epsilon is also a palindrome. So here the smallest palindrome is epsilon, after that A and B. Okay. So we want to generate these small strings and all of these. There will be infinite number of strings over A and B, which are palindromes. Okay. Now, whenever you are constructing a grammar, we must take a start symbol. Okay. Here I am taking a start symbol S. Okay. What is grammar? There will be non-terminals, terminals, productions, and start symbol. S is start symbol. And every time take the smallest strings as direct productions. Means S derives A is the smallest string, S derives B is the smallest string, and S derives epsilon. These are the productions. S derives A, the smallest string. This is one production. S derives B for smallest string. S derives epsilon. This is the for smallest string. So take the smallest strings as the direct productions. Now we want to derive the remaining strings. This one, like this one, this one, this one. So many. Example A, B, B. Okay, this one. all these things we need to derive. So how to derive? So look at this here. Remember the symbols before and after the non-terminal. See, S before is A and S after A. Now, and here the palindrome is over A and B. That is the reason ASA and BSB. These two productions and including these three, we do all the palindromes. Let us check. I am starting with S and let us take ASA, and this time in S place we can substitute ASA or BSB or A or B or epsilon. If I substitute epsilon, then this will be double A, is a palindrome. Okay, or if I substitute A, then triple A is a palindrome. Or in S place if I substitute B, then ABA is a palindrome. Otherwise in S place if I substitute ASA and then epsilon or B, it will be palindrome. Or now in S place you have to DSB. Now look at this. Whatever we are getting here in this direction, it will be reversed. Okay, let us take now this time again you substitute in S place. I will go for ASA. ASA already this is. See AABA and this is also AABA. And finally S will be replaced by either epsilon or A or B. So these are the productions which can give all the palindromes over A and B. So what is the grammar now? What is the perfect grammar? The grammar is, the full structure grammar is G equal to, we required only one not which is S. And the terminals are A and B. And the productions are P. And S is the only symbol that will be the start symbol. Now, what are the productions here? Productions are S there is ASA and S there is BSB and S there is A, S there is B and S there is epsilon. Now, these are the productions. So, this is the grammar. So, you understand? Copy this. Okay. Next. You understand this one? Hello, Teja. You understand? Okay. Now I'll give you some questions. You try. Construct a grammar for the following languages. Construct a grammar for the following languages. This is WC, not a subset. It is a C. WC, W transpose. Already we have seen this in regular languages. It is not a regular because relation and infinite. How did we choose? What is your question? How did we choose here? By practice, boss. Practice makes perfect. Okay, there is no rules and regulations. Based on the you only the rule is you go for the smallest strings as direct portions, and after that, so based on the requirement. Try this. Okay, if you get tell me, I will wait for few minutes. Try one by one. To see W transpose. First question I will try. Okay. Here W is any combination of A and B followed by C. W is any combination of A, B, followed by C, and it must be reverse order B, A. So whatever C before, C after, it must be in the reverse order. See, okay. So it is also a palindrome. It is also a palindrome. And what is the least string of W? W belongs to AB whole star. So the least string of W is epsilon. W is epsilon. If W is epsilon, then epsilon C epsilon transpose. Epsilon transpose is epsilon. Epsilon is C. C is the smallest string. Do you understand? Here W is the any combination of A and B. The least string is epsilon. Then epsilon C epsilon transpose is epsilon. Epsilon C epsilon is C. So take the smallest string every time. Okay, as a direct production. We required a start symbol. So for that reason I am taking yes. Here is C now, and after that W is any combination of A and B. So C before and C after we want only A's. So remember the symbols before and after, the non-terminal before and after, if they are same, they generate palindromes. So here the palindromes over A and B, and S finally will be replaced by C. So these are the only the productions. Look at this if you don't if you have any doubts. So S there is BSB. S is the start symbol. We must start from S. I took this one, and in S place now I substitute ASA. Now in S place again I substitute ASA. Now if S will be replaced by only the option C. Now look at this. Whatever this and this is in the reverse order. So this is the grammar. So what is the grammar finally? We required only one non-terminal S, and the terminals are A, B, C, and the productions are yes, there is ASA and BSB and C, and S is the star symbol. This is the grammar. Okay, so copy this. Do you understand? Take on Samiksha, Smita. Samiksha, what happened to you? If you do like this, how can I take the class? Now, what is the time? When did you join? So be punctual. Do you hear me, Samiksha? Smita, you got it? This one? Okay. Now, this is the grammar. Next. Try this one. Okay, copy this. Next. Next question. Problem question, just wait for some time. Okay. Next question is this one, you try. Okay. Did you try this one? A power n greater than or equal to 0. Yesterday we have done this question. Hello, yesterday we did this question. What are the strings in this L2? What is the least value? What is the least value of n? N value, the least is 0, a power 0, epsilon, a power 1, a power 2, a power 3, a power 4, so on. So we need a one start symbol and go for epsilon, and we want the remaining strings, so go for AS. That's it. Okay, these are the productions. You can see the proof here. AS, then epsilon, we will get A. Otherwise, in S place again AS, then epsilon, we will get A square. Otherwise, in S place AS, then S place epsilon, then we'll get A cube. Otherwise, in AS place again AS, then epsilon, will get A power 4. Like this, you will get all these things. Therefore, the grammar is S is the start symbol, and A is the S is the non-terminal, A is the terminal, and the productions are AS and epsilon. These productions you can write in any order. Okay, and S is the start symbol. This is the grammar. Okay, next. And for this, so this one. Okay. What is the least value of? Very good. Least value of n is 1. If n is 1, then a square. N is 2, a power 4. N is 3, a power 6, a power 8, so on. Even number of a's. So go for the smallest string, AA. And we want the even number of a's. So that's it. This is the grammar. So these are the productions. Okay. Now what is the grammar? Simple. Next time onwards, I don't write the grammar. Okay. S is the start symbol and terminal. Sorry, non-terminal, and A is the terminal. And okay. P is a set of productions. Productions I wrote above, and S is the start. So this is the grammar. Okay. Now this one. Yes, it's good. So smallest strings, smallest value of the least value of n is 0, then epsilon if n is 1, and if n is 2, and if n is 3. So here A's and B's are equal. So go for the small string every time. Yes, there is epsilon, and we want the missing. So S there is ASB and S there is epsilon. That's it. These are the This is the grammar. Okay. So I don't write the complete structure because you know what is what. So S is the non-terminal and A, B are the terminals, and these are the productions. Okay. Now we'll go for next one. Next. Try this. Okay, that's good. That's good. Here S5. The smallest string is epsilon, and n is 1, ab square, n is 2, a square, b power 4, n is 3, a power 3, b power 6, so on. Okay. So S derives epsilon. Here the b must be whenever you generate a, you generate two b's. That's it. This is the grammar. Okay. Whenever a is generated, we will generate two b's. That's it. Okay. Next. L6 not correct. Semester. And L5, Samisha L5 A or B, A, epsilon. L5 is this one. L6 not correct. Samisha not correct. Ah. Samisha L6. See what is here A is part by B. You are saying that AS, BS, ASB epsilon. Okay. Here, however you substitute AS part by B should come. I'll take BS. In S place, I will substitute AS. Now in S place, B. So again, S place AS. So it is giving AS part B part by AS part by B. Not. No. What is the grammar here? Now what is the language here? A part by B is only. The order should not be changed. Angel, angel. Okay. However you substitute However you substitute, the order should not be changed. You must get, however you substitute the productions, you must get the only the valid things. So look at this. I will use capital A to generate A power M. I will use capital B to generate B power N. So I need a start symbol S. S there is AB. Okay. And A will generate A power M and least value is epsilon. M is 0. So that is the reason AA follow and epsilon. And the B value, B generate B power N and 0. So BB and epsilon. So this is the simple grammar. Okay. Now look at this, whether it is correct or not. S there is AB. Okay, S is the start symbol. In A place we will take AA. And A place AA. And suppose now instead of A's place I will substitute in B place, B production, BB. And then in A's place I will substitute. In A place I will substitute AA. Okay. And then in B place. However we substitute, A's comes first, then B's comes. Okay. So this is the perfect grammar. Okay. Here, can you give a different grammar for the same language? Can you give a different grammar for the same language? Same, for the same, this one. Very good. Samik is good, but ASB is not required. Okay, it's good. Okay, the second. Here, this S derives AS and epsilon. Very well, you know that this gives epsilon A square, A cube, so on. Means it gives A power M, M greater than or equal to 0. Suppose these two are the productions, this will give epsilon B, B square, B cube, so on. Means it gives B power N, N greater than or equal to 0. If I combine these two, this and this, so then what will be the grammar? S there is AS, BS and epsilon. If I write like this, it will give the valid strings as well as invalid strings. So invalid strings should not be produced. Okay. What is the problem if I write like this? You start with AS or BS. I start with BS. Then S place I will substitute AS. In S place this time I will substitute BS. And in S place I will substitute this time AS. So it gives all the combination of A and B. Actually, what is the language? It is a language A is followed by B only. It is not A is followed by B is followed by A is followed by. It is not all the combination of A and B. Okay, but this alone gives A power M. This alone gives B power N. If you mix this, it is giving all the strings of A and B. So what is the solution for this one? Look at this. This gives A power M. Okay, no problem. No. Okay, no. Look at this. S direct S, then epsilon. Now look at it, give epsilon direct. Now take S direct SB. In S place, if you substitute epsilon, it will give, or in S place again SB, then epsilon it gives B square, or again SB, then epsilon it gives B cube, like so. This will give B power N, N greater than or equal to 0. Now I will combine these two productions. Means S derives AS and SB and epsilon. Now, however you take these productions, okay, example, yes, and I will go for SB. And in S place, I will go for AS. Now in S place, I will go for SB. And now S place, I will go for again SB. Now in S place, I will go for again AS. Yeah. So however you take, A's comes first, then S, then B's. So S before always A's comes, S after B's comes. And finally S will be replaced by epsilon. So this is gives this grammar grammar gives only A's followed by B's. It won't mix any of the A's and B's. So this is a perfect. And this is correct. And also this is correct. But here we have used 3 non-terminals, whereas here only 1 non-terminal. Okay. Now copy this one. Next question. And Samiksha, you wrote ASB. ASB is not required. Okay, you wrote extra ASB. What did you write here? Yes, there is AS and ASB and ASB. ASB is not required. So this is not required. Next, L7. However, we use number of A's must be more than the number of B's, and the order must be A's followed by B's only. The order should not be disturbed. Yes, there is AB. Samiksha. And what is AB? Hello, are you trying? Okay. Look at this. However you substitute, A's must be more than the B's. Okay. Don't copy, just listen. ASB. This generates equal number of A's and B's. So as long as I go for ASB, look at this ASB. Again in a place ASB. Okay, again in S place ASB. So as long as I go for ASB, okay, it will give A's and B's equal. Are you following? Okay, so you understand? As long as we go for ASB in this, okay. Now in S place ASB, again S place ASB. So it is giving, A's and B's, that is A's followed by B's only. And finally, I replace, go this side. So what is the smallest value of n here? The small or least value of n is 1. If n is 1, then m should be greater than n. So if n is 1, then m is 2. Then the smallest string is AAB. So that is the reason I took the string directly. Now in S place, if I substitute, already this is A cube. In S place, if I substitute AAB and this is B cube, okay. So finally, what is the string? A power 5, B power 4. So, or in S place again ASB, then if I substitute this one, I will get A power 6, B power 5. So this grammar, see, this gives equal number of A's and B's, and when I substitute S, when I replace S with this AB, we will get one extra A than the number of B's. So this will be the grammar. Sorry, this will be the language. But what is the language do I require here? It required any number of A's for any number of B's, and A must be greater than this. Example, I want A power 10, B power 8. But this grammar, this whatever I have considered here, this is only A power 10, B power 9. Whereas I want, when A's are 10, I want B's 1 to 9. This won't give a 1 to 9. It gives only A power 10, B power 9. When it cannot give, when A's are 10, it cannot give B power 1, B power 2, B power 3, so on, B power 8. So it only generates this one. It cannot generate these strings. Do you understand? So I repeat, this is for equal number of A's and B's. This is for exactly 1 A extra. But if you want more, see simply, when B's are 10, this grammar will give only A's are 11. But we required A's greater than 10, means 11, 12, 13, 14, 15, 100, 1 lakh. No. And B's are 10, it will give only A power 11. But we required more than 11 also. So what is the solution for this? Here, Tamiksha, you have given one solution. The problem with that solution is you wrote S dash AAB and A dash AA and epsilon, B dash BB and epsilon. Okay. Miss, I am taking S dash AAB. In A place, I will substitute epsilon. In B place, I will substitute BB. Again, BB. Again, BB. So like that, BB. So here the B's we are getting more than A. So this is not correct. You understand? However you substitute, the A's must be greater than the B's. Okay, and moreover you must get all these. Okay, here no doubt every time A's will be more, but A's will be only exactly one more than the number of B's. Only one extra number A than the B's. But here what? Suppose B's are 10, it will give only A power 11. We must get A power 12, A power 13 also. So what is the solution? Anybody? Solution for this? Teja, Smiksha. Anybody? No solution? Okay, look at this. S derives ASB. What? S derives ASB. This gives what? A's and B's equal. A's and B's equal. Okay, now when it is replaced by this one, exactly one A than the B's. Okay, this is for equal number of A's and B's, and this is exactly one extra A than the B's. But we want more A's. Okay, so that is the reason we must take A's. So this is for more A's. This is for only one extra. This is for equal. Let us check. S derives ASB. I will start with this one. Now in S place, if I substitute as many times you substitute AS, that many more A's you will get than the base. Okay. Now in S place, if now I substitute this time ASB. Okay. Now again in S place, I will substitute ASB. Okay, as long as I go for ASB, it will give. And if I want more A's, already this is A power 4. And in S place, this time I substitute AS. Okay, so as long as you go for ASB, it will give AC and B is equal. And if I go for AS, so if I substitute one time AS, it will give one extra A. If I substitute again two times AS, then it will give 2 A. Three times AS, it will give 3 A's extra, like that. And finally, S will be no doubt, even though you don't go for this production, when S is replaced by this one, guarantee 1 A will be extra. Okay, I repeat, this is for equal number of A's and B's. This is guarantee 1 A extra. If you want more A's, that is for AS. Okay, and simple grammar. You understand? Any doubt? Hello? Any doubt? Okay. Miss, this gives what? Equal number of A's and B's. And when okay. S gives ASB. Again S place ASB. Again S place ASB. So as long as I go for ASB, it will give the A's and B's equal. And yes, if I replace with AAB, so here A's guarantee 1 extra, no doubt. But if I want more A's, if I want more number of A's than the B's, then here we cannot generate AAB. Okay, Samiksha, okay, let me come to this one. If you want more A's than B's, then I'll go for AS. Again I go for AS, again go for AS, and finally S will be replaced by AAB. Okay, now Samiksha, you are asking for AAB. Now look at this, Samiksha. Go for AS. Then S is AAB. This AB. Now what is this total? AQB. समझ गया? Hello. Any doubt? Okay, Monday to next week, Monday to Saturday, you'll be having evening classes. Okay, and this week, today is the last class. And I have given you some questions. Please try. Okay. Here is one question. Just tell me the answer. Very simple question I'll give you. Tell me the answer for this question. Think and give the answer. Samiksha, are you sure? Oh, oh, really? All are wrong. All are wrong. Hello.
Sir,
Hello.
can a to the power n, b to the power n, and c to the power m, where n is greater than 0 and m is greater than equal to 2.
Greater than equal to
2.
2. None is the answer. Then why did you say A? Huh? Overlook the Here A derives B and epsilon. Suppose A is a start symbol, then you know very well it gives epsilon AB, A square, B square, A cube, B cube, so on. So this will give A power n, B power n, n greater than or equal to 0. Okay. And B's productions are P, C and T. Here the smallest string is C, and if I go for BC, then B place C, it will give C square. Like that C cube, C power 4, so on. So here it is C power m, and m minimum value is 1, so m greater than 0. Therefore, here actually what is the start symbol here? S is the start symbol. S there is A B, and A place A power n, B through A you will get A power n, P power n, and B place C power m. So here n is greater than or equal to 0 and m is greater than or equal to 1. This is the language, but it is not even. By mistake, by overlook, everyone will go for this one, which gives you negative marking. So here the right option is D, and the right answer is A power n, B power n, A and B is equal 46, minimum is 1. Okay, and minimum A and B can be 0. You understand? Okay, now, guys, do you understand? Okay, next. So grammar is completed. Let us go for. Shall we go for a new topic, or shall we go for some questions? Yesterday I gave you some questions. Na? Will you do those questions, or shall I go for a new topic? Okay, I think you have the mobile with you. Okay. So Smita, what do you say? First, you message me that first we will try. Means shall we go now or not? Smita ji, what do you say? Okay. Next 102 question. Question number 102. Why today only 3? What happened? Teja, can you reply? What happened to others? Teja, do you hear me? Okay. So try 102 question. 102. And Samiksha and Smita, you are from which branch? CSEIT. Teja, you are from CS or IT? Samiksha CS. Teja CS. Smita from the same. Okay. So from IT, no one has replied. And from CS, only 3 students. What about others? So definitely you will have more students in your class now. Okay, anyhow leave it and try 102. You have the questions with you in your WhatsApp. Okay, try 102. Teja is here del of Q naught comma epsilon is Q2. The meaning of this one. Del of Q naught comma epsilon is Q2. At the same time, Q naught comma A is Q1. And Q naught on B is Q naught. That is the meaning of this one. Okay? Right? Okay. Well, it is very simple. Whenever a question is given like this, it is easy if you construct the diagram. Q naught on A is Q1, Q naught on B is Q naught itself, and Q naught on epsilon is Q2. This is next. Q1 on epsilon is Q2. Q1 on A also Q2. Next, Q1 on B, it is Q. Now Q2 on epsilon naught. Q2 on epsilon naught. Next, Q3 on B is Q2. So this is the diagram for the given transition table. You understand? Okay, now if the machine starts at Q2, if input symbol AB, input string AB is given, after scanning this string completely, to which state the machine will go? That is the question. Okay? Now, Q2. The machine is at Q2. Q2 on E. It is not defined. It is not defined. So, what will happen here? So, here Q2 has defined for epsilon. So, initially it will take Q2 on epsilon. It comes to Q0. And Q0 on A, it goes to Q1. And Q1 on B, you can see Q1 on B, it comes to Q3. Now the input symbol is here. Q3 on A. Q3 has not defined. So the machine stops. So you cannot say the machine will reach Q3. When we can reach Q3, the string has to be completed. Here the string is not completed. Okay. So Q2 on epsilon comes to Q0. Q0 on A, Q1, Q1 on B, Q3. Q3 is not defined for A. Okay. Now we have to go for the other alternative. Okay. Look at this. Epsilon in Q2 on epsilon goes to Q0. Okay. Now Q0 on A, it goes to Q1. Are you following? Now, in Q1, instead of taking the B, look at this one here. It goes to this Q2 on epsilon. So, in Q1, instead of taking this B, it takes epsilon, it will go to Q2. And in Q2 also it takes epsilon, it goes to Q0. Now in Q0, it takes the B. See, B, it is defined here. Q0 on B, it will be Q0. So Q0 on B, it will be in the same state. Now Q0 on A, it is different. Q0 on A, it comes to Q1. So Q0 on A, finally it reaches to Q1. So the machine can stop in Q1. Are you following? The machine can stop in Q1. Or look at this. Q1 can move from Q1, the machine can move to Q2 on epsilon. So in Q1, it takes epsilon, it can go to Q2. Now the machine can stop in Q2. So machine can stop in Q2. Or in Q2 also, the machine can take epsilon and it will move to Q0. See Q2 on epsilon. It can go to Q0. And in Q0, it has not defined for epsilon, so finally it stops in Q naught. So it can stop in Q1, or it can stop in Q2, or it can stop in Q naught. Okay, so the possible states the machine can reach is. So what is the answer here? Q naught, Q1, Q2. Option C. C is the right answer. Do you understand? Hello? Can you explain it again? Wow. Teja, what happened? Teja, look at this diagram. Q machine has to start from Q2. Q2 has not defined A, so it takes an epsilon. It comes to Q naught. Okay. Then in Q naught it takes A. If it takes in T, it goes to Q3 and it stops here. So it don't go in this direction. Don't go in this direction. Now Q2 on epsilon Q naught A, Q naught on A. You can see Q naught on A. It is Q1, Q1 on epsilon Q2, Q2 on epsilon Q naught. Now Q naught on B Q naught on A Q1. So finally the machine can reach to Q1 and it can stop here. It can stop in this, or it can go freely. It's a free move because epsilon is there. It can go to Q2 and it can stop in Q2, or Q2 machine can move from Q2. It can move freely to Q0 on epsilon. So the machine can stop here in Q1, or on epsilon it comes to Q2 and it can stop here, or from Q2 and epsilon comes to Q0, so it can stop in Q0, Q1, Q2, or any of these. So these are the possible states the machine can reach. Samiksha, you didn't understand now? Shall I explain? Shall I repeat? Samiksha, repeat कर दो, or do you understand? Okay. This part, do you understand? This part, why we cannot go to Q3? Because if we go to Q3, input symbol will be left. Do you understand that part? This part. Q2 on epsilon comes to Q0, Q0 on A, Q1, Q1 on B, Q3, and until it reaches Q3, and Q3 A is not defined, so it stops in Q3. So we cannot take Q3 because input string is not completed. Do you understand this part? Okay. Now the other way. Q2 has not defined for A. So Q2, the machine takes epsilon. On epsilon, it comes to Q0. Okay, here the input string is A, B, A. Now in Q0, the machine takes A, it goes to Q1. In Q0, A goes to Q1. Now in Q1, actually this input string we are writing like this: epsilon A, epsilon, again epsilon B. Okay, A, this way. And after that also epsilon, epsilon. We are writing like this. Okay. Now Q0 on A, it has reached to Q1. Q1 it takes epsilon. On epsilon comes to Q2. In Q2 also it takes epsilon. You can see this diagram. It goes to Q0. Now in Q0 it takes B and it remains in Q0 only. Now in Q0 on A it comes to Q1. Now the input string is completed. So the machine can stop Q1. Okay. Or in Q1 it takes again epsilon, it reaches to Q2. Now the machine can reach stop in Q2. Or in Q2 also takes epsilon, it can take epsilon, it comes to Q0. So the machine can reach Q0 also. So these are the states can be reached. Now shall I repeat? Shall I repeat now or do you understand? Yes. Go, don't disturb. Next question. 100. The minimum possible number of states of a DFA that accept the regular language. Try this and tell me the answer. Did you complete this question? Next. The minimum number of states of a DFA that accept the following language. W1, W1, A, W2, such that W1, W2 belongs to A and B, and modulus W1 equal to Q and modulus W2 greater than or equal to 3. This is 2 and modulus W2 greater than or equal to 3 is. So the minimum number of states of DFA. So tell me this answer. Tell me the answer for this. Are you following? You know everything. Only you sincerely try. Tell the answer for the question. I'm trying. You got it or not? Okay, here W1 followed by A followed by W2. W1 length is 2. So W1 can be A or B followed by A, and W2 minimum length is 3. So 1, 2, 3, or it can be more than that. This is the string. So no one is giving the answer. What happened to you? Theta, are you listening or not? Hello, mister. Are you there? Now, W1 can be length, should be length 2. So, first symbol A or B. Second symbol can be A or B. And third symbol must be A. Okay, after that, W2, length 1, length 2, and length 3. And you can have more than 3. So, this is. Okay, here this is not a DFA. Why? Because see, the first state has different for A and B, this one, and second state for different for A and B, but third state we have not different for A. Okay, what is the language here? The language, look at this language. The first can be anything A or B, second can be A or B, anything, and third symbol must be A. If third is B, don't go to the final state. If third is B, then go to dead state. Suppose third is 8 comes to this, and fourth can be anything, fifth can be anything, sixth can be anything, then after that it can be. So these are the number of states. How many? 8. 1, 2, 3, 4, 5, 6, 7, 8 states. So 8 is the answer. Why no one has tried? Are you there or not? Please respond. Hello? Samiksha, are you there? Teja? Then if you, so because your network issues are there, so I'm unable to understand whether you're there or not. Okay, so why didn't you give the question? This is easy question. Huh? 8 states. Okay, next. 98. Try the 98 question. I wasn't in the class where you taught. Oh, then have you not gone for the recording videos? Question 98. Okay. The regular expression is given the number of states in the minimal DFA that accept the language represented by the regular expression. This is the regular expression given. Tell me the answer. Okay, I'll give you 2 minutes of time. If you don't get, just ask me. Okay, don't waste the time. Three states wrong. Wrong answer. How do you say 4 states? Teja, how do you say 4 states? No. The expression is not correct. What kind of string this expression will give? No. Teja, my question is, what kind of string this expression will give? tell me in words what kind of strings this expression will produce. So you are not doing the practice. So what do you mean by these strings, Samiksha? No. String of length more than 2 is not correct. If you are unable to understand the expression, then how can you solve this? What kind of thing the expression will produce? You are giving the examples, but you are not saying in words. Good. 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 Give me 2 minutes of time. Come. What kind of strings this expression will produce? This one. Here, are you there? Guys, here, any combination of A and B. This is any combination of A and B. Followed by any combination of A and B, followed by A3 or A or B or B or B or B. Then followed by B. After B, it can be A or B. It is of length 1. Okay. Now, here, this expression will give all the strings having B as the second symbol. Second symbol from RHS. We have done this similar question. Construct a minimal DFA that access all strings having A as the third symbol from LHS, having A as the second symbol from RHS. We did these two questions. Do you remember? Hello? Are you there? Samiksha? Okay. Now, having B as the second symbol from RHS, the smallest string. Okay, I told you, having A as the second symbol, or I told you, A as the nth symbol from LHS, we have n plus 2 states. From RHS, it will have 2 power n states. This note I have given you. Okay, let me complete this diagram. Here, having B as the second symbol from right side. So what are the smallest strings? BA and BB are the smallest strings. BA and BB. So accept BB first, or accept these two BA and BB first. So I am taking one initial. This is for B, and this is for BB, and this is for BA. Okay. Now, here we must complete this one. This is valid. What about this one? This is also valid. This is also valid. Because all these strings are having second symbol from right side is B. So accept that. Now this one, yes, because the second symbol is B. So here A comes, go to this. And if B comes, no, because the second symbol is here, don't accept. So here B comes, we go back to non-final. Now here A comes, yes, it is second symbol is B. So A comes, will come to this final state. Again A comes, no, then go to non-final. This. And here again A comes, we will be in the same state, initial. And again A comes, B comes, come to this state. And here B comes or A comes, yes, suppose B, yes, this is B, and for this B will come to this. So 4 states is the answer. So we did this. We can go to the previous construction of DFKs. Okay. This is for today's class, and tomorrow I start the new topic, that is construction of DFKs. And meanwhile, whatever the questions I have given you in WhatsApp, you try them. If you have any doubts, you can contact me in the WhatsApp. Do you understand? Hello. Samiksha, I don't have any notes. Samiksha, I don't have any notes. So just sitting in front of the laptop, and whatever I'm getting in my mind, I'm teaching. That's it. So I have notes. Right now we don't have any notes. Okay. And just ask madam for the recorded videos. Better. OneNote document, okay. You can, how to send this OneNote document? Look at this. This is this. Look at this. This having A as the second symbol from RHS and third symbol from LH. A as the. Look at this one. A or AB. A or AA. This one. This is for AB, and this is A as the symbol from RHS to 4N. 2 4N states. This also you may not understand completely, because everything I didn't write. I wrote some parts. See, here I didn't note. Actually, I dictated something. What is this note actually? The minimum number of states of LDFA over A comma B that accepts all strings having A as the. So from this, it only I wrote. Before this, whatever this before, I didn't write. So what is the note here? The minimum number of states of DFA over A comma B that accepts all strings having A as the n symbol from RHS is 2 power n. Similarly, this is from LHS is n plus 2. I will see whether I can send you or not. You just message me your mail ID. I'll try. Okay, miss. Okay, that's all for today's class. So tomorrow we don't have class, and next week, as per your previous discussion, we'll have the class in the evening, Monday, Tuesday, Wednesday. Okay, and Samiksha, send me your mail ID to my WhatsApp number. Okay, thank you.